Okay, so just to have a bit look ahead over the next weeks. Okay, we are approaching the last two topics of the course. So today we are going to finish the discussion about useEffects and the integration, client-server integration. Then we have a couple of weeks, week 12 and 13, where it's not written yet, but we'll deal with the user authentication, so login, passwords, all the stuff. And finally, we go and spend some time about, say, preparing for the exam and trying maybe to analyze together some possible exam text and to see, after all, the topic that we saw, how to approach maybe the design of a new application. Okay, right now we did it step by step, according to the new topic that we learned through the way. But now we start to see one big text at the beginning and see how to organize, how to reason about organizing the routes, the clients, the server, the APIs, and so on, which is the topic of the course. By the way, the first exam date is the 20th of June, right? And since we publish the text normally 20 days ahead, at least 20 days ahead, so we're going to publish before the 1st of June, and in the last week, the 3rd of June, the text for the first exam will already be out, already be published. So we are planning to spend 1 hour discussing the text of the exam, so that if you have any questions about or clarification or something is written in a way which is not clear to you and so on, we can discuss them in class and that we clarify them. Now, normally when we publish a test, we have a window of 1 week or so to get your comments or questions in order to clarify it, so that we can you can, when you can start working, we have a final version of the text. Okay, because every time you write some specification, there's always some gray zone where it's not very clear what to do or what is required actually. Okay. For the first date, so this is in general, we publish a text, we leave a window for questions and comments, and then we publish the final version, which normally has some clarification or some minor corrections. For the first date only, we have the chance of doing that in class, so that will be the discussion and the clarification on the text of the first exam will be on the last week. You see that last week we only have classes on Tuesday, while the Friday will not be used. So Friday 5th, what else, 5th or 6th of June is not used. You remember that we did some extra hours at the beginning of the course, and so we are recovering them now. So that the 3rd of June will be the last class for the course. Okay, but we have still some way to go, and my plan for today is to have a look at all, or not all, but many corner cases or troubles in the usage of useEffects and API calls, because when things start being asynchronous on both sides, interesting things may happen. First, I need to tell you something about useEffect that I didn't tell you the first time. You remember that we had this seemingly simple API for useEffect. It just requires one function and a list of dependencies. Okay, and we saw that the function is called whenever at least one of the dependency is changed. It's easy. So one of the pitfalls of the things that we have to clarify, we'll clarify later today, is what happens if the dependencies contain complex objects. Okay, what does it mean that they change or not? What kind of equality, let's say, criteria is used, and that could create problems. We'll see that today. But the other detail that we didn't comment yet is that there is this sentence: the callback may return a cleanup function. So we already saw this slide, but we didn't comment on this line. What does it mean? It means that in useEffect we can decide what happens at component mount time, okay, So the first time the function is always called. We can do something when some dependencies change. So we can list some dependencies and so trigger some function to be called. But we also have the opportunity of executing some code when the component will unmount. Okay? So remember the life cycle of the component, mount, update many times, and unmount. How can we specify what happens at component unmount time? Well, we can have a callback to be called. Of course, we specify a function, and this function is not listed here. Okay, it will be the return value of the callback there, which is totally unintuitive. So that you have a useEffect. The first argument is a callback, the normal function to be called with some dependencies. That's okay. This function normally just doesn't need to return anything. Okay, normally doesn't return anything. The body of the callback of the useEffect. The effect just runs and does stuff. Okay, normally we'll update some state probably. But if it returns something, it may return a function. And this function would be a cleanup function that will be called when the component, or just before the component is unmounted. So actually, if you are, for example, having some timer, some interval timer that you use for doing some kind, I don't know, of animation or continuous update. So you set up an interval timer that will tick every time. When the component is mounted, you start the timer. We will have its own callback for doing stuff. But sooner or later, then you need to stop the timer, because otherwise, when the component is unmounted, the timer, which is in JavaScript, will still continue running. Okay? So before the component is unmounted, we should every time at the mount time, we create some resource that is long-standing, that continues to exist. Then at unmount time, we should free that resource. It's not very frequent that we need to do that, because in many cases, if we follow as much as possible the functional style, we will never have any resources standing between different renders. Every render has its own resources and works with the state. But if we have external resources, like, for example, an external connection to an external server, not with the fetch API. The fetch API sends a call, I wait for the return, and the response returns, and it's all in the same run of the component. But if you had other type of updating mechanisms, like WebSockets or something else that we are not covering in the course, then you will open a connection at a given point in time. You are using this connection over and over at different refresh. Everything in effects, inside effects, so everything we are talking about here is outside the normal render cycle. But then when the component is destroyed, you want to close the connection, okay? To avoid that actually the server timeouts because it doesn't find the other endpoint. So every time you are creating some resource that by itself will continue to exist, remember to shut it down before the end of the component. So as I said, it's not frequently used, and it's not, let's say, really intuitive, because it also looks like, you see, the effect body, the callback of the effect, is run every time there is a trigger, okay? So actually, every time the body will return a function, it looks like this function could be different at every run. Actually, it's only the first one which is considered. But syntactically, it looks like the body of a function can return a cleanup function which is different every time. I would have probably designed it as an extra parameter. We have the setup function and then the cleanup function. The reason why it's embedded here is that the cleanup function might need, or usually needs, some closure over the resources that we have inside. So if here the side effect will open at a timer interval, we need to remember the idea of the interval in order to shut it down during cleanup time. So instead of having, so it is the kind of return statement. So this is the reason why we said that the API for useEffect is very dense, because there's a detailed return statement which opens a word of cleanup functions. So this slide, sorry, is in the wrong place. This one is in the wrong place. And this has a consequence. Stupid one, but since the return value of an effect callback is the cleanup function, then the callback itself cannot be an asynchronous function. Because an asynchronous function, a function that you define with async, by definition, returns a promise. And a useEffect callback, by specification, returns the cleanup function. And the two are incompatible. So we'll see it, and I show, because last time when we developed, I took care of that, but without, without. So, for example, we had this here. In the answers, we have this useEffect to load the answer for a given question. Okay. So load answers is an async function. We define that as an asynchronous function in API. Okay, and one could wonder, okay, but it's an asynchronous function. Why did you use the old syntax using then instead of just an async? Sorry, an await statement. It would be more natural for me, okay, or easier to write, okay, let's load the answers as an await of the response of this asynchronous function. And then, of course, set answers. Okay, these two lines are exactly the same as the first one. The first one is all using the older say then syntax for promises. The second one is using await. Okay, logically it's all correct. The problem is that if I use await, the function in which I'm calling it must be an asynchronous function. That's one of the rules of async and await. And so I should define this as an async function. And this is the problem. If I define this callback as an async function, it automatically gets a return value, which is a promise. And then React will try to interpret this promise as a callback function and try to call the promise, which doesn't make any sense. Okay, so at component unmount time, I will get an exception, an error. Actually, the warning is already telling me that effect callbacks are synchronous, okay, and cannot be defined as asynchronous. And the suggestion is, if I want to use an async function, and so using the await syntax, which is simpler and so on, I need to define an internal async function and call it in a synchronous way. This means that we can write this code, of course, okay, but we should wrap it into an asynchronous function. We call it async, for example, let me say that, no, sorry, const, the function is loader, which is an async function doing this. and then synchronously we call loader. So you see that the body of useEffect is a callback with a synchronous callback with one statement which is a synchronous call to a function. This function is asynchronous and it will be executed on its own time, of course. So I'm scheduling the call to this function. Actually, I'm creating a promise that will resolve when the I'm not waiting for the resolution of this promise. I'm just closing. Okay? But this will continue asynchronously. So in order to be able to use await and the new syntax for promises inside the callback of useEffect, we should wrap inside the callback and all the instruction inside another function and call it only once outside with a synchronous call. Okay? So actually these two lines were at first sight more convenient. When I see all of this, probably that's why I'm reconsidering that the old syntax could be, in this case, it may be simpler. Or depends on, of course, it depends on what we need to do. So if you are using then and catch and so on, we are just working with callbacks, and so we don't need to do anything special. If we want to use await, we need to have an extra layer function inside. And this leaves us, of course, the possibility of returning the callback, the cleanup function. Okay, so it will be a function that does do some cleanup if we need it. So it's the synchronous execution of the code and then the return of a callback that may or may not be called. Of course, depends. If you have a component like app.js which is only mounted and never unmounted, this callback will never be executed probably. Okay, so these are the two different possibilities that are equivalent. So that remember that await requires an extra layer of functions inside a callback effect. All of these callbacks, so this one for useEffect and also the one for the cleanup, don't have any arguments. So React is not providing any parameter for them. So all the information they need should be recovered from their closure in the function itself or in the component. So that's one tricky thing we have to do for a functionality, the cleanup functionality that we normally don't need. But anyway, that was part of the design. So in summary, we have sort of 4 ways to use to call useEffect, or in other ways, 4 ways of specifying when to execute our code. Okay? We can have some code that will execute once. And this, is achieved by providing an empty dependency list. It will only run at mount time. The other way, some code which is only running at unmount time is specified by providing a cleanup function in the return statement of a useEffect of any kind. Then we have the other, so at the beginning, at the end, and in the middle. In the middle, we have some function that runs many times. After each update, if we don't have any second argument, or after some updates, if we have the dependency array. So according to the first of all, we ask ourselves, when do I want this to run? And then we see how to say create the second argument, how to define the second argument of the useEffect call. Okay. And also remember that we already saw in the console that the useEffect, well, we already saw that the components normally are rendered twice, okay, in development mode. This is a self-protection of React that will check whether you're doing something right or wrong. Whether you are following the functional style for your component. Also effects in development mode tend to run twice. Okay, so we should try to avoid, and these are if you want, it's a feature of React that makes life more difficult for us, or just forces us to think about what we are doing. Okay, the idea is that again, an effect is called by React, and every function called by React may be called, especially during updates, may be called many times, because the update of a component is decided by the framework, not by me. And so we should be careful about the possibilities that an effect is run more than we expect, and it shouldn't change at all the user experience. Okay, we should not depend on the effect being run 1 or 2 times and so on. So if we have some operations that are critical, like the submission of a form or something like that, we change some data, save some information somewhere on the server, they should not be called inside effects, they should be called inside event handlers, on submit of the form, on click of the button. That is guaranteed to only run once, when I click on the button, wait and submit the form. There is the place where we do, say, destructive or non-reversible operations. Effects are just for the reverse, when we get some extra information and we want to incorporate that in our application, not when we are sending information out. So if we get extra information, we do a call from outside, like we did here. Is there anything wrong if I call this? This only runs at the beginning, of course, or every time a question changes. If it's called twice or 3 times, does it change anything? Well, of course, it will call the API more times. It will slow a bit the application, but it doesn't change the result. No, it's not. Doesn't create any damage or any different behavior. Why? We see that the other example that we had was for the upvote, which is somewhere down here. The upvote function that came from, I don't remember, with the component API. Okay. We saw that the upvote operation, where we are doing something, when we are changing some data, is defined as a normal function linked to an event of the user. It's not an effect. It's not a user effect. It creates some side effects, but they are triggered by some user actions, so they should live inside an event handler. Effects are used for when some external data changes, and so we want to run some code because data changes. Use effect. We want to run some code because the user does some action, event handler. Okay, let's not miss the two. We don't need a use effect for the upvote. We could use a use effect for incorporating the results of an upvote. Maybe some numbers change, so we want to update something in the interface. Okay, that would be a reaction. Okay, and we can have a use effect linked, for example, to the value of the answer, the updated state that has been updated in the event handler. Okay. So this, I suggest you have a look at this article, which is linked there. That points out to 2 use cases where it's maybe it seems or maybe you can think, okay, let's use a useEffect here for handle this case, and it's not a good idea. One, the first point we already mentioned last time when we saw an example of using useEffect for example, remember, computing or displaying the length of the number of answers, okay, which was something that was easier to do by just directly computing or recomputing the data. So when you just transform data for rendering, it's called here, compute some value that is depending on props and states, just do that synchronously in the render, okay, and repeat the computation. Don't set an effect which will create a second state that you then will have trouble to keep in sync with the first one. It is also a consequence of the fact that, as a rule of thumb, state variables should be independent. You should never have a dependent variable, otherwise you didn't plan your state very well. And the second case, what we were seeing right now with the upvote functionality, is don't use effect to handle user events. Okay, sometimes I see some code where the user clicks on something and then the callback changes some state variable, and this state change triggers an effect that then does something else. So it's an extra step which is useless. Maybe also dangerous, because changing a value, you should always be sure that the new value is different, otherwise you risk that you are setting a value which is identical and you are skipping an update. So the effect will not run if you're not careful in some cases. So it's not, never use, let's say, state variable for synchronizing operation. So setting a state so that something else runs. Use events for events and state for states. So the actual scope and role of useEffect is when you really want to get information from outside, okay? And so this just be careful not to use it for synchronizing the internal of your application. We didn't do that, but when I see that some code usually zip through. Okay. This was the first point. Now, there's another shortcut that we took last week, and then we worked together today, exception handling or error handling. Okay, we were just assuming that everything went right, but with API calls and effects, but what happens when it doesn't? Well, there may be many cases. We saw that we are relying basically on a fetch operation, okay, whenever we do some API call, which is run asynchronously. The result of the fetch is captured by even an event handler which is asynchronous, or a useEffect callback which is asynchronous too. So the issue is how to handle in the user interface the error condition. In the user interface, we can just start the operation and then wait for the result to arrive. Okay, we should be aware that the result could be the result that we are expecting or an error condition. And errors can be of different kinds, of course. Just to see one example, if this is the same code as last week, so I didn't modify anything. I'm starting the client without starting the server, for example, okay? And so if I open the application, what I see here is an empty page. Okay, actually, what I didn't see, because I didn't have the console and I'm not managing the errors, is that there were some errors. Okay, because remember, the server is not running. Okay, so the browser, first of all, is complaining about calls, that because nobody responded, so it didn't have the permission to go ahead. It was a timeout, basically. But we have this second error. So the first one was easy to solve. We just need to start the server. The second error is very interesting because it doesn't tell us what we are doing, and it doesn't tell us where we are doing it wrong. Uncocked in promise, and then network error and so on. Uncaught exception in promise. So it means that there was a promise somewhere in our code. It doesn't tell us where. This is friendly. Where the promise rejected, but we didn't catch it. So in this case, we have a type error exception, which is strange, caused by a network error. So the real error is this one, network error. So the promise could not connect. And we launch this promise. We know what it is because it was where we are loading the list of questions. But we are not handling that condition. So what we should do here is, let's go to the API. We know we are here in load questions. We made this fetch, and the fetch is launched this promise, and this promise failed. Because actually when trying to open the connection to the server, no server was listening on that port. We were lazy, we didn't manage the exception. So we should remember how to manage the different type of error in a fetch statement. Remember that there are two types of errors. One are network errors, in this case, and then we have application errors. So the server that communicates that something went wrong. The first type of error, and network errors, is normally called generates an exception, as we saw. So we could wrap this like this. And then we run some code, catch. Okay, so we know that we have a normal try-catch statement. Remember, fetch returns a promise. So we either use the promise with .catch, with a callback, or we await, and the await transforms the rejection of a promise into an exception in the code. Okay? So in this case, we have, let me just try if we are catching correctly. Let's say a network error in load questions. And let's see the error object that we are getting, what it says. So let's first try, see whether we are able to catch the error, and then we decide how to handle that. So if I reload this application, of course, the same error happens. And now we have my message type, network error in load questions, and so on. So this is my message, and this is the string contained in the exception object itself. Okay? So at the API level, we can okay, there's at the API level we can catch this kind of errors, and then what do we do after that? Maybe we should display a message, something like that, some error, loading error occurred, or something like that. Okay? We should display some real feedback to the user. But here inside the API, you cannot do anything on any of that, because we don't have the generation of the user interface here. What we could do is, inside the component This is the list questions component that called no, was the question up. Yeah, we are calling the load questions here in up. Okay, so the problem is now how to communicate the error condition to up and let up handle that in some way. Okay, we should not mix the data with the error condition, of course. So normally the API function returns a list of questions. In the case of an error, we must return an error message or an error condition, and it's better to handle that as an exception. So either the API returns the data or it throws an exception. And then we should catch the exception at the user interface, at the component level. Okay, so we have an exception that comes from the network level. We handle that and we analyze it probably, and we rethrow it for the component to be handled. So here, okay, I leave this log for debug purposes, but then I throw a new exception. I don't want to throw a network error because maybe some other cases, but let's say error in general. And then I may put some, you see them, some string, some message string inside. Error in, yeah, we could do the same here. The same message, now it becomes plus the exception. Okay, so at this point, we are just recognizing the error and throwing an exception. So what is the application doing? Net quote error and load. Again, we have an uncaught exception, okay, because we have a promise that rejected, and there's nobody who's catching this rejection. But now we are one level above, because now who is complaining is the component. Okay, we are inside load questions, inside up. So right now, the issue is that this promise, load questions, is not handled. The rejection of this promise is not handled. What we could do is to add a catch standing here. So we are using then and catch, or we could use await, but then we need to wrap the function as we saw before. So we catch the exception, and we do something with this exception. What we could do, we let's say sanitize the error. The error is there. We cannot do anything at this point. We should only display, tell the user something went wrong. So we should anticipate in the user interface one place, one space to display an error message. So this means that we are, let's say, incorporating into the application state the error condition. We could have an error message which is we may set or unset according to whether something is wrong or not. And in the user interface, we want to display that. So what the useEffect can do is to set the error message. Set error message to loading error. Please try again. Or something that makes sense. Okay? We don't need to display the content of the exception because it's not normally something that the user is able to read, but it's up to us. We are transforming the error into some user interface where the user can understand what is happening, or that something happened. And now we should use this error message somewhere in the render code. So the render code for main is made of different routes, which is more difficult to handle, of course, because we should find a place where to insert this message. But let's first start and see what happened. So if we reload the application, why you're still giving the errors? Yes, X38. Did I say? Oh, I didn't save it, sorry. Okay, you see that we got rid of the uncaught promise error. We still have a course because the server is not running, but we managed that, okay? And if we inspect the components, we should see that app state now contains an error message with our loading error and so on. So right now it's just an issue of user interface. We are rendering right now the header, and it's okay, and nothing more right now. The list of all questions comes from, sorry, a render route. Okay, then in the outlet we are rendering the list of questions and so on. Probably we should display the error before this header list of questions, because we don't have the list of questions at all. And then we should modify the logic for the routes. And header, we are in slash. What could we do? I'm thinking about where to write the message, the error message. That should prevent. Well, let's do something easy. Let's say here. Maybe if I have an error message, then we display it, just to see. Okay, right now it's here at the top. We should move it somewhere. We should a bit reorganize the outlet for showing this error message. And this is displayed every time, and you see we don't have any remaining issues. If we now start the server, now we reload the application, the error will, of course, will go away. We don't have any more exceptions there. Okay, so now we say had to skip 3 levels. No? We have the network error, the API, the useEffect, and finally we have a React state that we can manage in some way. We should also say that something is wrong, so say all of this is only displayed if we don't have any errors. For example. So in this case, you say it's okay. In other cases, we should render something. We could render something completely different. If I'm stopping the server and reloading the application, it just doesn't render the application. What an error page? We can have a navigate to an error page. We can do whatever we want. We have this information. But now it's all React. We have a state variable, and we use it for deciding how to render the error. Maybe it also depends on the type of error, whether it's recoverable or not, or something like that. Okay? So this was one type of errors, so the network errors. And then maybe that something can go wrong for other reasons in the server itself. Okay, so this is a simple API, fetch question. So let's move to the server. Let's go one level below. So this API comes from a server. We have the server.js, where we just call this API questions. And this API, when we designed it, we were already aware that in some cases we had a result to give, in some other cases there may be an error. So at the API level, an error is encoded through an HTTP status code, different from 200, different from the default. In this case, the API is returning an error. In this case, it's just an error code. There's no error message. There's no reason. We could also send, instead of writing and, we can send some text with the error, with an object describing the error. In this case, we are not doing that. We are just saying, okay, 500, close the connection. And the code for this error is something that happens in list questions, in the database function. Okay, so if list question returns a promise that this promise could reject, and it will reject if there are some issues with the query. Okay, so we may have some problem with the query. The query will cause this function to reject. The rejection will cause the HTTP request to fail. Let's put a syntax error in this query. Okay, I save this, the server will restart, and my application would not run, probably. Okay, what we see is that at the network level, we have some get that returns a status code of 500. And this status code of 500 caused an error in the JSON parser. Maybe we didn't expect it. It's not the type of error that we expected. Let's go into the code. So the API.js, actually the error is triggered by this statement. The fetch itself was successful. It didn't create any exception, because a 500 status code is a valid status code. So the HTTP call was okay, and we didn't throw an exception on the fetch. We have an exception on the .json code because our response was empty. And so we were trying to parse an empty JSON. In this case, this catch captures an error, an exception given by JSON here. We could also be more explicit in trying to check whether the status code is valid, okay, before trying to process it. So there's no meaning in trying to process a response when we know that the response is not there. So what we should do actually is not to execute this code. We know that the response went wrong, and what we could do is to check the OK property of the response. Now remember, when we saw fetch, OK is a property that is true if the status code is 200 or 300, and is false in the other case with 4 and 500. So some application error happened, and the server communicated that with status codes. So if the response is OK, we can go forward with this stuff. Okay? Otherwise, there was some application error that, again, we should communicate to our caller, to the component that called this function. And so, again, we throw new error, which is, in this case, an application error in load questions. And we don't have any exception object here. There's no exception being thrown here right now for the moment. It's only data, so we don't have an exception to read. So the result is the same, of course. Where's that? If I reload it, I see the 500. I see the loading error there. If I check the component, I see that app, the state, now contains the message. No, loading error, sorry. It's why is that? Application. Okay, because this error, it was let's put okay, so that we see in the log what is happening. In this case, reload, and we see that app received the error, application error. And there's also this network error. Why are we printing it twice? Okay. Okay, so actually always have to do this kind of double error checking at the network level, and it would be a checking the exception of fetch generated by fetch with a try-catch statement, and then possible application errors. By the way, we still need to do extra checks maybe. So if the response is OK, it only means that the server returns a 200 status code. Then we should see the content of that code. Maybe it's an empty list. In this case, it would be right or not. Maybe some wrong data. I don't know. Okay, so maybe at this point we could have also some validation of the data returned by the server to decide whether the call was successful or not. The idea is that we should return a value only when we are really sure that it's a valid response. Because our React component is just trusting that data. We're receiving the data, setting into a state, and this state value will determine how the interface is rendered. So it's better to do all the possible checks here, where we have the knowledge of what is happening at the low level, the JSON encoding, the network problem, and so on. And when we return something which is already valid. We don't want to give the burden to the React component to manage special cases, okay, as much as possible, because and in all the other cases we throw some exception and we let the component to decide how to display that. Okay, so if we now can re-put it again, we are solving it. There's no longer any exception running there. So this, as always, with error management is always boring, because we turned one line into a bunch of checks and different ways, but it's quite, say, copy and paste or structure or something, all with the same thing. But we should remember to do that. Especially because, as we saw, the initial error message was totally unclear. Uncaught promise. Where? For what reason? Okay. And if we leave it too many places unprotected, then when we have this error, it's possible that it will be difficult to debug, actually, because we see there's error, we know that something is wrong, but it's hard to keep track what is actually wrong. So let me remove some logs, otherwise my console. Okay, so this would be the pattern that we're using every time we use fetch. The APIs are not just returning some data, but may also be returning some exception. And the same goes here for load answers, which is the same. Okay. Maybe it's even in load answers there are more things that can go wrong. Okay. For example, it may happen that the response is empty, and this is a normal case. A question doesn't have any answers, any replies. It's okay. But if the question ID is wrong, it refers to a question ID which doesn't exist. Does it make any difference? Should be able to tell the difference. Does the server tell us any difference? Because from the application point of view, having a question with no answers is one thing. Having a wrong question, a non-existent question, is an error. And maybe at the server level, let me check. At question, we had list answers of. So what we are doing is a select from answer with the same author, with the question ID. Yeah. And this is running well if the question ID exists. It returns some rows or 0 rows if there are no answers. But if the question ID doesn't exist, it will happily return an empty list. So the return of this function is the same. So in this case, we should think again about our API. Where should we detect this kind of error? Probably this API, I don't know if in DAO or in server, where we have the answers, we have this list answers, and we are just returning the JSON. So probably already here we should return some error saying invalid question. So before doing that, we should check in the database. We should do a first query whether the question ID exists, then run this. Otherwise, return an error. So in this case, it will be an error, an application error, which is not a syntax error in the query. It's not something which is, but it's the current state of the application is incompatible with the request that came. Okay. So from the point of view, the database is the same. I'm asking for an empty set, but the problem is what I asked for. we should, so we are thinking this right now because we didn't think about it when we designed the API. We thought, okay, we have a question ID, then get the answers. But if the question ID doesn't exist, we should block it here and return an error. So in this case, the 500 status is not okay. It's, if you want, for the errors in the query, but also probably for the errors in the so in this case we may have different reasons why we are creating an error. So in that case it would be wiser probably not just to send an empty response, but to decide a format for an error response. Okay, if we have an API that can create many types of errors, there's no standard here. We can decide our own. We can create just a, I don't know, a text string or a simple object with a code or a message, an error message that we can capture on the other side of on the client. Was there a database error or was there a data validation error? So in this case, for example, we could imagine, I don't know, say, okay, we don't just want to, in this case, we have an exception, okay? So if the exception happens, we can just maybe return an object with error, database error, maybe. But in other cases, like we were checking before calling the list answers of, maybe I want to call the API that gives me checks if a question exists. So if a question exists, we have a get question. Okay. The get question API was already considered in this case. So probably it's wise to ask the get question first, and it returns. So in this case, we implemented that with a resolve, not with a reject, in the case of the error. So we are resolving to an error object or to a question object. It was our choice at the time. So we can use it here. So we have load questions. We can have await, load questions with the same parameter. And then we check the result. Because if question.error exists, sorry, it's the other way around. Then we have a problem. Otherwise, we can go forward. So this means that the attribute exists and is not empty. We can result.status 500. We set an error, an application error with an error object with a message that comes from question.error. Something like that. And we can test it directly. We had, for example, did they have? No. So we had the API for the list of questions. What are? Okay, sorry. There was some error here. In the server. lot questions. Oops. Get question, sorry. It was get question. And we had a problem, but probably, yeah, this is a very, I used a load question, which was a function inside the API.js on the client side, which has totally nothing to do with the server. So, but the autocompletion found a function, and tried in the server to import. You see, we are in the server code, server.mjs, and trying to import something from the client space. Because I wrote the name of the function, and the editor just added the import statement, which is something, of course, that will never work. Okay, so this is a problem that we have in the same editor, both the server and the project and the client open at the same time, and so Visual Studio Code sees that as a unique project and tries to find. So this is something. At least in our mind, we should really have a total separation between the client and the server. Okay, if we have two computers, use two computers. So now it should work better. So questions. Okay, now we can try to see what happens if we are trying to read questions number, sorry, copy, paste, question number 1. And we get the result of question number 1. This is what already working. If I'm asking for question number 11, is now returning this error message. So we are exposing through the API some application error condition. It's not a database error, it's just invalid data, some data which is not valid. And now, if we want, we are going back to the client. Here, the result of this fetch, this response, the JSON of this response may contain the object of the answer, sorry, of the question. Sorry, no, we are still one step back. This was, sorry. Okay, so this is the question 1. Okay, and if we add the answers, because we were talking about the answers. Okay, we get always the same. So, in both cases, we are returning this error message. And if we want, in the API, we can check for that. So, we call the API goes through, but the result contains an error condition. So, in this case, we should go all the way, try, and put everything into a catch, an exception, then do something like we did before, for example. And this for network errors. We know that we don't have any network errors at the moment, but we may have some wrong error code. Okay, so for example, if response, like before, is response okay, we go forward and we try to parse the answers. Blah, 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 the map, create the object, and return everything. And otherwise, if response is not okay, because what happened here in the server is that we sent the error message with a status of 500, so will not be okay in the fetch call, but we can extract the reason. So in this case, it would be else const error await response.json. Okay, because we know that in this case we have a body on the response that contains an error message. And then how to pass this error back to the caller through an exception. Again. Okay, so throw new error with error message, for example, and so on. So it's a matter, now we are just playing and trying to add, it's a matter of being very clear about the different levels, the database, what does it return, the database function, what do they return in case of a problem, and what are the problems. The simplest one are SQL errors, but other ones could be data validation errors. What does it return? Then what the API does in the different cases. So the API can basically catch some condition in the database queries, but may add some validation of its own. May also validate the parameters. Maybe if ID is a string or it's missing, then it generates an error in the validation phase. So the easy part is take a parameter, call an API, call a query. Okay. And the hard case is validating before doing the query and checking the result of the query itself, and returning some error information, which will be embedded in the error status code, and maybe some object or string that describes what happened. Then we move up on the client side, on the fetch, on the API that does the fetch statement, and this is what the reason why I want to write this code in a separate file, because it gets messy, because there's just one line for calling and many lines for error checking. So we are checking the network condition, we are checking the HTTP status code, and in the case of a file status code, we are also checking the reason, and we can do something different. And the only way we have to communicate with a component is through an exception. Okay? And this exception is then caught in the event handlers or in the useEffect callbacks. And finally, at the end of all this, we are setting a state with a message, with a Boolean condition or something like that, that will block the rendering or modify the rendering on some part of the page. Or maybe trigger some other condition, or retry, automatic retry, I don't know. It depends on the error. Okay, so basically whatever happens in the real world, in the network level, in the database, and so on, it will all go into some React states that report the condition to the user. These are, in this case, all the examples that we did now are non-recoverable errors. Okay, so the application can do anything. It cannot load the data. Let's stop there. Okay, but there may be other cases in which maybe we are rendering something different if we have this kind of error condition. There's just one point before saving it. We are setting an error message by never resetting it. So actually, it will try to be optimistic at the beginning of useEffect. Let's reset the error message. And then if something goes wrong, I'm setting it. Okay, so in this case, it only runs once, so it's not an issue. But in general, once we have some error message, we should also think about how to reset the conditions. It should not be stay there forever. So we have some extra state for managing this error condition. This, in case, is an error in app, because app is responsible for loading the list of questions. But the same logic also should be propagated to every component which has some kind of data loading. So So this is the sort of, let's say, the minimum error handling we could do. The minimum is I don't want to see any exception in the server side, so in Node.js or in the browser console. So during a normal behavior, exception should be all exceptions should be handled. We know where they are called, so they are all there. Okay. So we don't need maybe to handle all possible error conditions in a nice way, but at least let's not let the exception go to the browser console. Okay, try to, when you debug, try to keep the console open. As soon as you see an exception, try immediately to fix it as soon as possible. Then we have other problems to care about. Okay, so we are here in exception handling, where the difficult part is really, it's not difficult, but try to keep a clean documentation, okay? Not just, it's easy to reason about the results, it's not so easy to reason about the possible error condition, and we should do that as much as possible in a uniform way. So if your API returns an error object in many calls, the error object should always be the same, and the status code should always be the same, so that it makes it easier to manage and not having a different way of reporting error for every API call that you make. Okay, I think it's time for a break. I will not talk about errors anyway anymore today, but you know the drill. But there are other conditions that we should be aware. One of them is, and the first that we'll talk about, since we already have the client and the server open at the same time, delay. Okay, what happens when the server is slow in loading? So you navigate to a page and nothing happens, or because you're waiting. Right now it's quite immediate, but imagine having a database that responds after 3 seconds or 5 seconds or 30 seconds. And so what is the application expecting to do? How to manage that? But first we make a little break, okay?